Now let us do a numerical from the echoic part. Is a man stands in between two cliffs and he fires a gun, and he hears two successive echoes, one after the 2 seconds and second one after 4 seconds. So he hears two echoes, and the question is, what is the distance between the cliff? So he hears two echoes, one after the 2 second, one after the another one after the 4 second. The question is, what is the distance between the cliff? Before getting into the description or how to solve this, let us see what an echo is. When sound gets reflected from faraway objects and reaches your ears after 0.1 seconds, then you are able to interpret it as a second sound, not as a continuation of the first sound. And this repeated hearing of the sound is what you mean by the echo. So it must reach your ears after at least after 0.1 seconds. Now why it is called after 0.1 second? Because our ears have the persistence of hearing. That if it reaches before 0.1 seconds, our brain will interpret it as the continuation of the first sound. So it won't consider it as a second sound. It has a continuation of the first sound. So that is why it is said it has to reach your ears after reflection at least after 0.1 seconds. Now normally the speed of sound at 20 degrees Celsius is taken to be 332 meter per second in air. So means in 1 second it covers 332 meters. So in 0.1 seconds, so in 0.1 seconds, it will cover 33.2 meters. So the sound must at least travel 33.2 meters after the sound has been produced to reach your ears to interpret it as an echo. So if the object, so means sound has to go to the reflecting surface and get back to you after 0.1 seconds, and that distance which the sound has covered for going to the reflector and getting back to you must be at least 33.2 meters. So in one side, so total is 33.2, so one side it should be at least half of this. So that is why it is 16 point, so we consider it to be 17 meters. So the first point to be noted is that the object must be at least 17 meters away from the source which is producing the sound to be heard it as an echo. So the object, the reflecting surface must be at least 17 meters away. That is point number 1. Point number 2, the reflecting surface should not be smaller than the wavelength of the sound. If it is smaller than the wavelength of the sound will surpass it or overpass it and won't get reflected. And third point is, so sound must have the point number 1, it is 7 at least for an echo to be heard properly. So for echo to be heard properly, the distance between source and reflecting surface must be at least 17 meters. Why 17 meters? I already told you. It must reach after 0.1 second. So after 0.1 second means it must cover at least 33.2 meters. So one side it must cover at least 17 meters. Second one is, it must, the reflecting surface or an object size must be greater than the wavelength of the sound. So reflecting surface or object size must be greater than wavelength of sound. Otherwise the sound waves will overcome or surpass the reflecting surface. Then point number 3 is the sound must have enough intensity or energy to get back to the source. The sound must not be that much feeble so that it once get reflected won't reach back to the source again. So enough strength should be there or intensity. So if these three conditions are satisfied, you can hear an echo. Now, what is the equation which we use to solve this type of questions? See, here is a source and is the reflecting surface. Let the distance between the source and the reflecting surface be d. So sound goes to the reflecting surface, gets back. So one side d, another side d. So 2d distance it covers, and let t be the time taken. So distance covered by time gives you the speed or the velocity. In this particular case, even though the direction is changing, let it be velocity of sound. So v is equal to 2d by t is the equation which we use to solve the questions related to echo. Why 2d? One side d, the other side d, that is the total distance covered, and it takes a time t, and so velocity, distance covered by time gives you the velocity. Now getting back to the question. Here there are two cliffs. And person is standing somewhere between the cliffs and he fires a gun and he hears two successive echoes, one after the 2 seconds, second one after the 4 seconds. Now if we assume if he is standing in between the cliffs at almost a half mark, so the time which he is taking to hear the echo must be same because he is at the middle. So obviously he is not standing at the middle. From the given description itself you can say that he is standing somewhere nearer to one of the cliff. So let he is somewhere here, and the distance, total distance is d. Let this distance between the first cliff and the second and the person be d1, and distance between the person and the second cliff, let it be d2. Now he fires a gun. Obviously the sound will be moving in every direction, so that sound goes to the first cliff, gets reflected back and reaches him, and he hears it as the first echo after 2 seconds. So if you use the formula which we have already discussed, 2d by t gives you the velocity. Here t is given, t is equal to 2d by v, and velocity of sound is 332 meter per second. So t is known and v is known, you can find d. So in this particular case you can write 2d1 by v is equal to t1, and how much time it is given for the first echo? It is 2 seconds. So 2 seconds is equal to 2d1 by velocity is 332. So how much is d1? d1 is equal to 2 into 332 by 2. So you have 332 meters, that is d1. d1 is 332 meters. Hope you understood. The person fires the gun, hears the first echo after 2 seconds, when the sound goes to the first cliff, gets back, and it took 2 seconds. So distance d, again d, so 2d by v gives you the time is 2 seconds. So 2d by 332, that is the velocity of the sound in air. So 2d1 will be equal to 332 meters. Now when you find d2, time by which he hears the echo is 4 seconds, so same equation, t2 is equal to 2d2 by v2. So t2 is 4, 2d2 by v2 again 332. So when you cancel this 2 and 2, you will have 2 here. So d2 will be equal to 332 times 2. So 466. So 664 meters. So d2 is 664 meters. The question is, what is the distance between the cliffs? So what you have to do is you have to add d1 plus d2 gives you the distance. So 664 plus 332, so 699. 996 meters is the distance between the cliff. Hope you understood how to solve such problems. First of all, from the question itself you can understand that he is not at the middle. Second, you can understand he is near to one of the cliff. So you differentiate it as d1 and d2. So time taken, distance covered means goes to the cliff, gets back. So that is the total distance, that is 2d. 2d by t gives you the velocity. So when you use that formula, 2d by t giving you the velocity. From this you can find the d. Because the velocity value is given, it remains constant for a given medium. Here it is 332 and time for each case is given. Hope you understood this problem.